Got me falling right back.
Many controls inherit from the content control base class, including, surprisingly, button, and they can contain other controls. If you want to have a button that contains both image and text, not a problem, because you can have multiple controls within a button. If you want a list box that contains a bunch of text box controls, no problem, because there's nothing keeping a list box from containing any other kind of control. We'll start by looking at layout controls. Several controls are useful for laying out other controls, and those include the dock panel, which allocates an edge for each child control, and it's useful for defining rough layout. There's the stack panel control, which stacks its children either horizontally or vertically, and this is useful internal to other controls. For example, in a button, if you want to have image and text, you're likely to place them within a stack panel. I lied before. A button control can contain other controls, but it can actually only contain a single control. So if you want multiple controls inside a button, you have to place one of these containers, for example, a stack panel inside the button, and then the stack panel inside the button can contain multiple other controls. There's the grid control, which is a container for other children controls and arranges those children in a grid. There's no need for fixed sizes or positions if you're using a grid. You just lay things out within the cells of the grid. It also rescales when it's resized, which is very helpful for having a dynamic resizing interface. Finally, there's the canvas layout control, which has no layout logic, and you manually control each aspect of the layout when you're using a canvas control. Let's look at a demo now that works with layout controls. I've cleaned out my user interface, removing all the existing controls except for the grid, and I'd like to demonstrate using a button as a container. But for the purposes of this layout, I want this a little narrower, so I'll do that now, and set the width property of the container to be 300. Now within the grid, I'd like a button control. Now I could drag and drop it from the toolbox, but that adds all sorts of extra attributes I don't care about. So instead, I'm just going to type it by hand. And nothing wrong with doing it this way. I'll specify the content, have that be click me, and I'll also specify a margin, just to show that I can, of 15. So there's my button, all ready to go. I'd like to place an image within that button, and some text as well, but let's start by placing an image within the button. Now I can come to the toolbox and drag and drop an image on, but unfortunately the designer doesn't understand that I want it inside the button. Why do I want it inside the button? So that I can click on the image and have it bubble its click event back out to its parent, the button, and trigger the button's click event at that point. That way I can have just one event handler for the button, not for the image as well. So I can easily just take the image and place it within the button. Seems easy to me, but clearly the designer doesn't like this. Why is that? If I hover over that, you'll see it says the property content is set more than once. And you're going to say, excuse me, I see the content property, it's only set once. The problem is that whatever you place inside the button element becomes the content property of that button. Well, you've already set the content property explicitly. Here, can't have it both ways. You can't have content set manually and within the button element itself. So I'll delete this one, and now everybody's happy. For this image, I don't want to specify a height or an alignment. I do want to specify a margin, but I want it to just be 50 all the way around. Name is fine, though I don't really need it. I'll call it demo image or something like that. The stretch property I'll leave as fill. We'll talk about that in a moment. I don't need these set. So I have an image, but nothing in the image. No image, no picture. So where is that coming? That's the source property, and I really would like to go browse my hard drive to find that. So the easiest way to do that is to go to the Properties window, look for the Source property. There it is. Click the button, click Add, and go find the source we care about. C:\samples is where I have this. There's an Images folder. There's our AppDev image. I'll click OK, and now we've added that image. And you can see here in the source property, there's a special formatting that allows the designer to find this so it can compile it into the project if it wants. What does the stretch property do? Let's try other options. Fill looks like it takes the image and makes it fill exactly the space it has to work in. Another option is uniform. Uniform modifies the size to match the exact dimensions of the image. There's uniform to fill, and that one keeps the size of the image control the same size it was, but doesn't change the aspect ratio of the image. And of course, none says don't modify the size at all, and just use the original size of the image. I'll put this back to fill for now, so it fills the entire space of our image control. So you've seen that we can either have an image or text, but we can't have both in the button. So how are we going to get image and text in there? In this case, we'll need one of our containers that we talked about. We talked about dock panel, stack panel, grid, and canvas. The one we need here is a stack panel, so we can stack the controls vertically. So for now, I'm going to move the image control out of the button. And in the button, I'll add a stack panel control. Of course, I could drag it from the toolbox, but since I'm only setting a few attributes, I'd rather type it from scratch. The only attribute I need to set is the orientation, which is going to be vertical. Now within that stack panel, I want to place this image. And what have we accomplished? Well, nothing yet. We've put a stack panel in here, which has an image that has a margin of 50. Great. But because it's a stack panel, we can put other controls inside here stacked vertically. Now you might look for a label control, and although there is a label control, it's really meant for using data. That is, for labeling data fields when you're working with data. For this purpose, the text block control is more appropriate. We'll set the text property to be click me. And there's our text block control. Doesn't look quite right. Let's set the horizontal alignment property to be center and the font size property to be 24. And there we now have a button with an image and text made possible because we use the stack panel control within the button. Clearly, a button can contain other things, but if you use a stack panel, it can contain multiple other things. Maybe for some reason you want to include a text box within your button, and you can. Let me remove this image and instead add a text box control. Let me set the text for that to be click me to. And now we have a text box and a button. So what you'll find is that because these controls in WPF are so flexible, you need to rethink how you build your user interfaces. Things you thought were impossible before are now likely completely possible because of the flexibility of the layout within WPF's controls. Here we've got a text box and a label, a text block in other words, within a button. Works perfectly fine. No reason you shouldn't be able to do things like this in WPF. Just as you can use a button as a container, you can use a list box as a container. But unlike the button control, a list box can contain an unlimited number of any other control type. If you want to mix text block, text box, combo box, and image controls in a scrolling list box, no problem. You can do it. In this example, we'll look at placing various types of items into a list box. I've cleared out my designer, so again we have nothing within the grid. I'd like to start by adding a list box. I could drag and drop it on. I find it easier just to type it from scratch and set the attributes that I care about. In this case, there might be a name property, although I don't need it for this example because I'm not going to interact programmatically with this list box. And I'll also set a margin so I can see exactly where the list box is. Now I'd like to add some items to the list box. I could do it here just by adding list box item elements and adding some text like item 1. And there's my first item. But I can also do this using the designer. So let me select the list box element, come to the properties window, and look here for the items property. There it is. And I'll click the button to load the builder for the items collection. I already have one list box item whose content is item 1. I can add another one and make it be item 2. And a third one and make it be item 3. So we have 3 items in our list box, but we can do much more than that. We can also add other controls to the list box, like a text box. And let me have a couple copies of that. Now, if I had given that text box a name, I would have to modify the name at this point because you can't have multiple items with the same name in the same scope. Since I didn't specify a name, I don't have to do that. But if I don't specify a name, how can I tell them apart when I want to work with them? But I'll let you play with that some other time. I also might want an image control in here. I will specify a name for the image. And for an image, of course, I'm going to want a source. So I'll go find the properties window, look for the source property. Now remember, I'm only filtering because I've already filtered. If I examine all of the properties, I could find the source property somewhere. It's here. I just find it easier to type the text here to limit the properties to just the one I want. Click the button, choose the image I chose before, click OK, and now my image appears in the list box. I can have multiple copies of that image, no problem. Don't imagine why I would. Can't all have the same name. But in any case, I now have a list box that contains text, text boxes, images. I can have as many of whatever I want in this list box because this WPF list box supports containing any number of any kind of control within the list box. Another common container control is the grid control. The grid control allows you to contain well-ordered children as opposed to real-life children. The grid's children appear neatly in rows and columns as you'd like your real children to appear. You can lay out multiple rows and columns within the grid container, and the sizing of those rows can be either absolute or relative. Let's look at an example that demonstrates working with the grid control. In my layout, I've again deleted everything except the container grid. And in this grid, I'd like to create a number of rows and columns. And again, the designer comes to our aid when it comes time to do that. So rather than creating anything in the markup, I can just come up to the grid, make sure the grid is selected, and it is, and I can come to the border, and you'll see as I come to the left edge, the cursor changes, and we get a little line indicating where we're going to be creating the current row. I've created a row there. Let's create another one here, and you can see that what I've done is create 3 row definition elements within the grid.rowDefinitions child element. Now, just like we saw earlier, I have to specify this as grid.rowDefinitions because there's no way to specify all this information in a single attribute. So we have to specify row definitions using the parent.property syntax. We have 3 rows. We can do the same for columns. As I come up to the top, I can click once to create a column, and then another column. So now my grid contains 3 rows and 3 columns. We can see that because we have 3 column definitions and 3 row definitions. We can get to the same place in the Properties window by looking for row here. And there's row definitions. There's a builder for this as well, and you can add row definitions and set specifications for those rows in the Properties here. You can do the same for columns in the Properties window. Now, XAML uses a specific mechanism for identifying sizes of rows and columns. You look at these and you see the asterisk there, and you're probably wondering, what is that asterisk doing for me? Well, let's stop and look at the column definitions. Let me change them to specific values. I'll change this to be 20, this to be 40, and this one to be 60. What does that indicate? Well, we've specified now fixed column widths. The first one is 20 pixels wide, the next one is 40 pixels wide, the next one is 60 pixels wide, and since the whole grid is 300 pixels wide, we have some leftover space, which isn't allocated to any column here. Of course, we could do the same thing with the rows, giving them fixed sizes. Let me change one of these to be just an asterisk. Asterisk means to use a relative sizing. Now, the trick is, the first thing that WPF does is lay out all the fixed width columns. In this case, that's 20 and 60. And then it takes all the remaining columns and allocates them according to the sizes indicated in their definitions. Let me add another one here to prove a point. You see, both of those middle columns have the same width. They're relatively the same size. Let me take one of these and make it 2 star, and this one be 1 star. If you look carefully, you'll see that this column, the third column, is twice as wide as this column, the second column. So here's what WPF does. It sets aside space for all the fixed width columns, 20 and 60. Then it takes all the remaining space and allocates them to the other columns. For those that have an asterisk in their width, it takes the numbers associated with those widths, 1 and 2, adds them up, and then gives the correct proportion to each one of them. So this column gets 1/3 of the free space, and this column gets 2/3 of the free space. Now, what if I change this to 10 and 20? Same exact thing. Or 100 and 200. Doesn't matter. Hopefully you get the point. All that WPF does is add up those widths that have stars associated with them and then assigns them proportionally. There's one other way to set up a column or a row, and that is based on the content. Let me add a button in here and set its content to be click me. There we are, there's our button. And I want this button to be in a different row and column than the 0 row and column, which is the default. So I'm going to specify grid.row equals 1. That puts it in row 1. And grid.column equals 1. Puts it in column 1. So there's our button in the 1 row and the 1 column. And you notice we used an attached property to specify that. The button doesn't have a grid.row property. The grid adds it to that button. How can we now make that row just big enough and that column just wide enough for that button? Well, let me change the column definition not to be 100 star, but to be auto. Auto makes the column just wide enough for the contents of that column, and the same for the second row. I'll make that one be auto, and now that row is just tall enough for that button. Of course, if I specify a width and height for this button, say a width of 100 and a height of 100, the row changes and the column changes width to make room for the specifications for that button. So now you can see that the way this grid lays out columns, for example, is it does the fixed width ones first, Then anything that's auto, it gets the size for that. Anything that's left over, it assigns to those columns that have an asterisk. So if I add one more column, those columns will be evenly divided. Here, one is half as wide as the other. And remember, that can just as easily be 1 and 2. And not putting anything in front of the star is the same as putting 1 in front of the star. So you'll have to remember when you see a star and you're doing the calculations to put a 1 there. So we add 1 and 2 together to get 3. And so this column is 1/3 of the free space, and this column is 2/3 of the free space. And everything I've said here for columns applies to rows as well. Now we've got a button here that fills exactly one cell. There's no reason why this button couldn't span rows or columns if we wanted. So there's a grid.column_span property and a grid.row_span property. We can set that to 2, and now this button would span 2 columns if its width wasn't fixed. So I'm going to get rid of the width here. And actually having this auto doesn't help me much either. So let me have this be, say, 40 wide. And you can see now that this button, whose width is not fixed, instead is set to span exactly 2 columns. Let me get rid of the height for the button, and instead have it span 2 rows. And there we are. So now our button spans 2 rows. Of course, it's hard to see that because the row definition is set to auto. It's resizing itself. So let me set that to something specific, like 20. And now you can see we're spanning 2 columns and 2 rows. And if I come set a margin for this button, 10 says 10 from the left and right. 20 is 20 from the top and bottom. And it looks kind of weird, but you can see that this button is actually contained within 2 rows and 2 columns. We're 20 pixels from the top and the bottom, and we're 10 pixels from the left and from the right. You can see you get a lot of flexibility using the grid.column_span and grid.row_span properties combined with the margin property to lay out exactly where your controls appear within the grid. Before we can finish up this demonstration, we need to talk about dependency properties. If you look at standard .NET code, a property is defined using 2 procedures. There's a setter and a getter procedure for each property if it's read-write. There's a more complex mechanism at play in XAML. Microsoft Workflow uses this same mechanism. Dependency properties, which are the kinds of properties we're using, allow for styling, automatic data binding, animation, change notification, and much more that standard properties don't support. So we'll be looking at dependency properties in XAML. The dependency property class acts as a base for all the properties we'll be working with, or at least almost all the properties. And dependency object is a base for classes that can consume and expose dependency properties. That is, dependency object is the base class for almost every control that you'll work with in XAML, and the dependency object class exposes a collection of dependency property objects. The XAML classes expose far more properties than their corresponding WinForms or WebForms classes, so there needs some internal mechanism, some internal plumbing to handle all these properties. And that's what dependency property is for. .NET maintains an internal dictionary of all the classes that are being used in your application and the properties that they expose. The dependency property instance is defined as a static or shared member of a class. There's only one of these for each class, each object you work with. In the constructor for the instance, code registers the property, its type, and the hosting class with the .NET framework, which then maintains the value of that property in a dictionary for you. You can optionally create a standard .NET property that wraps up the dependency property, and in every case of every control you'll work with, that's what the .NET framework has done for you. So imagine that you wanted to create a property called isAvailable. how would you represent that in code? For every property of every control you declare in XAML, there will be somewhere inside the .NET framework a declaration like this: a public, static, dependency property with the name that corresponds to your property. For the isAvailable property, we'll have a field named isAvailable property, and there's only one of these for the entire class that's defining it. It's a static property. In the constructor for the class, there's a method call, like this one, which sets the value of that isAvailable property by registering it with the .NET framework. You pass to the register method of the dependency property class, another static method. You pass the name of the property, the type of the property, and the class that's registering it. So now this information is registered with the .NET framework, so the .NET framework can maintain the value of this property. Of course, to make it available for you as a consumer, someone at Microsoft has written a wrapper which exposes it as a standard .NET property, which gets and sets the value of that field from the dictionary that the .NET framework is maintaining for you. It's like your code wants to get the value of the isAvailable property. Well, the .NET framework says, wait a second, let me go get it from where I've stored it. It goes to that dictionary and retrieves the value of this field for the particular instance you're working with. You don't have to worry about this except to understand that every property value is maintained by the .NET framework in a dictionary, and that happens because every property of every object is a dependency property. The reason I told you all that stuff is because you might want to programmatically interact with an attached property, and the only way to do that is by writing a little bit of code which gets the value or sets the value of the attached property. The button control doesn't expose the grid.column or grid.row property. It's the grid control that exposes those, yet those attributes exist in the XAML markup. They're attached properties. The properties are added by the container when the interior controls are hosted within that container. And you retrieve and set those properties using the dependencyObject.getValue and dependencyObject.setValue methods, just like the code you saw in the previous slides that showed how internal code does this. In order to retrieve information about the grid.row property of a button, you might write code like this. We declare a variable row as an int, and we're going to call the demobutton.getValue method. The button doesn't maintain the value itself. It calls a method which asks the .NET runtime to hand back the value it's been storing for its grid.row property. And the way we get that is we pass that one field reference. Remember, it's a static property of the grid class. There's grid.row property. We pass that to the getValue method of the demo button. The .NET framework flips through its dictionary, finds the correct value, and hands it back to us so we can store it into a variable. If we want to increment that value, which is what this demonstration will do, we call the setValue method of the button. We pass in again the indicator of which property we're talking about. That's grid.row property, for which it's a static property. There's only one of those. We pass it to the .NET framework. It finds the correct dictionary entry, and we give it row +1, and it puts that into the dictionary, setting the value for that property. It seems like a convoluted way to get or set the value of a property, but for an attached property, that's the only way we can. Let's look at an example that uses this technology. I've once again cleaned out our layout here. I'd like to add some rows and columns to the grid to prove a point. So here I'll add 1, 2, 3, 4 rows and 3 columns. I'd like to place a button within the grid as well. So let's go do that. I'll set its name to be demo button. I have to set its name because I'll be referring to it in code. I'll set the content. And finally, grid.column. Seem to have missed something important here. Yep, I put it outside the grid. It's not happy. Let's put it inside the grid. There we go. Life is better. Now, of course, we're going to want to refer to the grid in code as well, because my point is here, to be able to click the button and move it from one row of the grid to another. So I need to be able to refer to the grid, so I must give the grid a name. And I'll call it layout root for lack of a better name. That's my name for the grid. Now I can refer to it in code. I'll double-click the button. That takes me to the code editor, and here I'd like to retrieve the current row, increment it, and then set the current row. To do that, I'll declare a variable. And what's the value of that variable going to be? We'll have to cast my return value into that type. And I'll set demo button.getValue. Now, what do you pass to the getValue method? You pass a dependency property. And the dependency property I want to retrieve is grid.row property. I want to retrieve the grid.row property, and the name of the field that represents that property is grid.row property. And there we are. Given that row, I want to increment it by 1, but keep it within the grid. So I could write an if-then-else statement to make sure it never goes outside the grid, but an easy way to do this is to just take row plus 1 modulus the number of rows in the grid, which is layout root.rowDefinitions.count. That will work to keep the row number within the grid. And finally, I want to call demo button.setValue, passing in, again, the dependency property I'm trying to set, which is grid.row property, and the value, which is row. And you're saying, why can't you just set and retrieve the value of the property? It's sitting right there in my XAML. Well, if you try, you'll see there is no demo button.grid.row. It just doesn't exist. So we can't set it directly. The only way you can interact with an attached property is by using code like this to get and set the value given the name of the property as it's defined in the dictionary that the .NET Runtime maintains. The dependency property is grid.row property. When you ask to retrieve that value, it goes to the internal collection, the dictionary that it's maintaining, looks up the property and the instance, that is demo button, for which you're trying to retrieve it, and it returns the value it's cataloging for you. At this point, if I save and run this code, in my grid, I didn't show the grid lines. You can't see them, but as I click the button, you can see that the button is clearly moving from one row to the next as you'd expect. And this is only possible because grid.row property is a dependency property. The .NET framework keeps track of its value, and we can call the getValue and setValue method of the button control to retrieve that attached property. Clearly, you've touched only a tiny portion of the WPF features, behaviors, and functionality. You've looked at a few controls, seen how to interact with XAML and the various tools in Visual Studio for working with WPF, and you've seen how to programmatically use WPF's dependency properties. As you know, there's a great deal more to WPF than you've seen here. Use this section as a starting place and experiment on your own. Create your own application using WPF, but be prepared for stumbling blocks. Would you have found the syntax for working with the current grid row, as shown in the previous example, unless you learned it here? Most likely, it would have taken some research. WPF isn't an easy transition, but as a development platform, it's extremely powerful.
Promise that you'll catch your